I just have really loose thumb joints. You can actually feel them like, here, see if you can see it. Watch. You can see me put my thumb out of joint. Watch. You see me twist sideways? Like, there. That's where it goes out of joint. But it's not really quite out of joint. It's just really loose thumb joint. Anybody else do it? You can even do it with your thumb fist closed? I remember, so when I was in high school, I learned I could do this pretty early, and I can do it with both hands. And so I'd go up to my, I went up to my science teacher in like 7th grade. And I was like, I can't take your test today, I broke my thumbs. And he was like, whoa! And I was like, I'm just kidding. And he was like, get away from me, this is disgusting. And I was like, cool. All right. So 3rd hour, we did the broken thumb. And again, that's the only one that you won't be able to do with me. Every one you'll be able to do with me. Well, pencil trick is something that is a little special. It's hard to do. But anyway. All right, now we're going to do 2 examples. Everybody ready? Example 1. Yes, I'm in my notebook now. You can tell because I'm on the notebook page. All right, first one is going to be 3n to the 4th times 4n to the 7th. All right, if you multiplied these, the first thing we do is we multiply just the numbers out front, that 3 and 4, which makes 12. And then n to the 4th times n to the 7th is what? N to the 11th. Remember, you add those exponents. That's that rule we just did. Anybody totally forget the rule in a matter of 3 minutes and looking at my thumbs? Yeah, okay. That's why we have this. So you can keep looking back and going, what's the rule? Oh, I add them. Okay? All right, that's the first one. Ready for example 2? All right, go ahead and try this one. 7x y squared times 2x to the 4th y to the 3rd. All right. Anybody interested in trying this one for a prize? I'm going to offer you a giant poppet. It's a giant poppet. All right, 1, 2, 3, 4, 5, 6, Colin, 7, 8, 9. Seven.
That's me, right? Do you just multiply the 7 and 2 to get like 14x, and then would you add the exponents to the...
You add the x exponents together and the y exponents together, but Riley, there isn't an exponent on this x, so what do we do?
Oh wait, I wrote that down wrong. Would it just be like 7 times, so it would be like 14x 4?
Is this x to the 4th?
No.
Or you're saying this would be x to the 0?
Yeah.
But I disagree with you on that. Anybody have a better idea? Yeah?
It would be x to the 1.
X to the 1st. All right, Riley, keep going on the math problem. This is x to the 1st because that's 1x.
Yeah.
If there was 0 x's, it would not be there at all.
Yeah.
Okay? All right, so x to the 1st power is, that's just 1 to the 1st power. All right, so now what's my x? X to the,
So it would be x to the 5th.
okay.
Would you add them
And then y to the
to the 6th? No, 5th. Yeah, you just add that.
5th. You just add them.
Would it
Okay.
Be, wait, what? Would it be 2y? Did you add them?
Nope.
Or you multiply them?
Okay, so the rules that we just did
So it would be
Riley?
the 1 then.
says that you take the exponents and add them, but see how the a stays the same.
Yeah.
So I'm not saying 2a or anything like that, just adding the exponents. So this is the right answer. Okay? All right, come get that prize. All right, remember we are doing 3 rules.
What are you doing? Are you the big poppet?
Yep. All right, next up, next rule. I'm on my rule sheet now. I'm on rule number 2. Rule number two says, What if we have something like this? Okay, let's say a to the m in parentheses. Riley, you're going to continue doing this, right?
Yeah.
Okay.
What?
A to the m, I just didn't want you to get obsessed with your thing and not write. Colin.
I'm not topping it.
A to the m to the p. Okay. So let's put it in numbers we understand. So I'm going to go over here on the proof side. Let's say it was x squared to the third. Now, what that would be is it's x squared times x squared times x squared. Do you guys agree there's three of them? X squared times x squared times x squared? That's right here. So whatever's in that parentheses, imagine it this way. Whatever is in that parentheses, you multiply by itself 3 times. And inside there is x squared. So it's x squared times x squared times x squared. Everybody okay with this so far? Okay, and then what is each x squared made of? 2 x's, or x times x, right? So actually I'm going to rewrite this x times x times x times x times x times x. Which makes what? Six x or x to the sixth? X to the sixth. What is the difference between 6x and x to the sixth? Dylan.
6x is just multiplying x by 6, but x to the 6 powers.
X times x times x times x times x times x. Yep, 6 x's compared to the number 6 times x. Okay, so can anybody guess the rule? If I've got a 2 and a 3 here, I've got this and these powers, then it ends up being x to the 6. So what's the rule? Grace?
You multiply the exponents.
You multiply the exponents, a to the mp. And if they're just right next to each other, you know that means multiply, right? You can put a dot in there if it makes more sense to you. All right. Let's do a thing. All right, what do you want to do? We already did the broken thumb.
How does the broken thumb even go in this now?
These are just fun little hand tricks I can show you. These are for fun.
It's for fun.
So it doesn't deal with this at all?
No. The only thing I'm doing is I am realizing that this chapter is the most boring one I teach, and I'm putting in fun,
Oh,
just to be nice. Can you believe it?
Do you want to pop it?
It is nice.
I'm actually being nice. Okay, but I appreciate, Kierden, that you're like, but what in the world does this have to do with? It doesn't. Nothing has to do with nothing. This is just me being nussball, okay?
Are you gonna print
Anybody have an opinion about what they want to see next?
it? Are you gonna print it? You want-
Dead finger.
Okay. Now, dead finger requires you to hold up your hand like this. What I'm showing right now is vertically, I'm showing them this. And you're going to kind of let your finger, your ring finger, just hang at that knuckle. So the best you can make it, try to make it like a 90-degree angle right there. And this finger goes straight down. So you don't want it curved and you don't want it leaning back like this. You want to try to make it so your hand goes straight down like this. And then, if while you're holding it vertically, you tap, it feels like it's not connected to your. Isn't that weird? It feels like it's not connected at all. And it feels even weirder to do this. Look, touch that knuckle right here and try to bend it back and forth. Like it feels like it's not even connected to your hand because the joint is loose, just hanging there. Technically, you can do this with any finger. But I think the ring finger is the easiest to do it on. That's a weird one, right? Anybody do it with all their fingers?
You can't do it.
Yeah, right. Thumb is impossible, but can you do it with your 4? I can't do it with my pinky. I can't. I have a hard time, especially with my left hand. I have a hard time doing that angle. Yes, I can a little bit. But yeah, isn't that weird? Anybody ever see that before?
Yes.
All right, example 3. Some of these are more fun than others. You just have to deal with, sometimes things are fun and sometimes they're not. All right, n to the 5th to the 3rd. N to the 5th to the 3rd. So what do you do with those two exponents? Multiply them. What do you do if you forgot what you do if you add or you multiply? Look at your sheet. You've got a sheet right here that says exponential rules. Look at rule number 2. You see that if it looks like this, that you multiply those exponents. Okay, example number 4.